All right, guys, here we go. This is, we're looking at 9.3 right now, finishing up the lesson here. So for example 2b, another one of these double solution type examples. First of all, we always want to move these guys over to put this in standard form. So this becomes x squared plus 8x plus 16 equals 0. Okay, so let's factor this thing. Well, let's not factor it, but you could factor it. If you factored it, what you'd get this x plus 4 squared. That's the factor, okay? And you can refer back to some previous lessons to remember that this is a perfect square trinomial, so it factors to this. Okay, but say we don't know the factors. Let's just find our negative b over 2a. So that's our axis of symmetry. The axis of symmetry will be at negative b, which is 8, over 2 times a, which is 2. So we have negative 8 over 2, which is negative 4. So at negative 4, we have symmetry. Okay, so that's negative 4. All right, so, and that negative 4 is labeling this place right here. So we have symmetry there. If we plug a negative 4 back in, negative 4 squared plus 8 times negative 4 plus 16 equals 0. This turns to 16 because negative 4 times negative 4 is positive 16. 8 times negative 4 is negative 32. Okay, so we end up with this. 16 minus 32 is negative 16 plus 16 equals 0. So we get 0. Okay, so at negative 4, we are at 0. That is our vertex. Since the vertex falls on the line, we have one solution, and that solution is negative 4. Notice if I factored it there, it's technically a double solution because the factor is x plus 4, x plus 4. What makes this go to 0? The negative 4. Okay, so if you're looking for that shortcut. This thing has a y-intercept of 16. Okay, it'll be approximately 4 from there on this side. So we have a picture that looks like this. But again, the solution that we're looking for is where does it cross the x-axis, and that happens at negative 4. All right, so that's example 2 where we have a double solution. Example 3 is a no solution. Okay, so again, we're going to put this in standard form by moving this guy over. We have negative x squared minus 3x minus 5 equals 0. All right, so this thing's going to open down. The y-intercept, if you plug a 0 in, is at negative 5. All right, but let's find out where our symmetry lies. So we have negative b, negative negative 3, over 2 times negative 1. Negative negative 3 gives me positive 3. 2 times negative 1 is negative 2. So we have symmetry at negative 1.5. So at negative 1.5, we have this symmetry. Okay, to figure out where the vertex is, I'm going to plug that thing back in. So let's plug it back in and see what happens. If I plug in a negative 1.5 here, it's probably better actually when you plug it back in to plug it in using this. Or you can use the decimals if you want to, just convert it back. But anyway, let's plug it in. So we have negative parentheses negative 3 halves squared minus 3 times parentheses negative 3 halves minus 5. Okay, so if I do this, negative 3 halves squared gives me, since this negative sign is here, I'm going to keep it. So negative, this would be 3 squared is 9, 2 squared is 4. Okay, and then we're going to add, because we have a negative 3 times a negative, negative times a negative is a positive. This becomes negative 3 times negative 3 is positive 9 over 2, okay, minus 5. Okay, a little fraction reminder here, you guys. We have to find a common denominator, right? So in this case, that would be 4. All right, so we have this negative 9/4, which won't change, plus, if 4s are common here, what do we do to the 2 to get 4? We multiplied it by 2. So we got to multiply this whole thing by 2 over 2. Quick review of fractions. And we get that. And then we subtract 5 from this. Okay. By the way, though, if you want to take a little bit of a shortcut here, to turn 5 into fourths, what you could do is just multiply this guy by 4. right? So 20 over 4 is the same thing as 5, right? So I just converted this to fourths, so I can do this simple addition and subtraction. Okay, so now negative 9 fourths plus 18 fourths gives me 9 fourths. 9 fourths minus 20 fourths gives me, well, 9 minus 20 is negative 11 fourths. Or, that's approximate, well, let's figure out what that is as a mixed number. 4 goes into 11 2 whole times. We're left with 3. So we're at negative 2 and 3/4. So when I plug it back in, I'm at negative 2 and 3/4, which is approximately here. Okay, so my graph's drawn a little bit interesting because of the scaling that I did. Is that right? 1.5? Yeah, somewhere in there. 1.5, 1.5. So we have this kind of a picture. But the point is that we did not cross the x-axis. Okay, we did not cross this line at all. And the solutions is always where that happens. So the answer to this is no solution. Okay, no solution, which symbol for that is this guy. The solution is an empty solution set is empty. That's another way of saying that, but that's no solution. And I think that's it, guys. So there's another example possibly in your notes, but I'm not going to go over it here. The homework is 9 to 29 odds. This is odds. I don't believe this page number is correct, but I did give you guys a homework sheet. The page number, I can look at this real quick, is page 584. So page 584, do 9 through 29 odds. It's on the homework sheet. And hopefully this video helps you fill in the missing gaps from the lesson. Have a good day, guys.